Thank you for watching this video on how to create rational equations. Namely, we're going to be looking at work problems. Now, work problems for some reason give a lot of students a lot of problems. They're really nothing more than a rate issue. So when you have problems with work problems, there's really an underlying issue about your understanding about fractions and what slope is, because they're very much interrelated. So the idea and a definition, if you want, for work is rate times time. So the more time you have something, the more work you can get done. The faster your rate of work is, the more work you can get done. But we're not going to be using this particular form of it. What we're really going to be doing here is we're going to be focusing on a different form of this, namely work over time is equal to your rate. So that's what I was meaning a second ago when I said there's really just nothing more than rate problems. So if you have a decent understanding or a good, solid understanding of fractions, this process becomes a lot easier. So if you are having a lot of difficulties, it might be in your best interest to go back and review fractions, namely how to add, subtract, multiply, divide fractions, and then also how to solve equations that involve fractions. That'll make it a lot easier for yourself. Namely, if you want to do a search, there's a solving rational expressions is what you probably want to be looking at. I've made a video previously on that. So to start, average problems. The idea here is to remember that it's the total divided by the quantity, which is what I'm looking at here, is work divided by time. And if you think about the type of average you get for a class, the idea is that, yeah, you have an 80 and a 90 and a 60, that you add all of those three together and divide by 3. But what are the thing about that is kind of hidden is the fact that it's 80 out of 100, it's 90 out of 100, it's 60 out of 100. So the problem with work problems is it's not always going to have the same denominator. The reason why we could add all those values together and it still work is because we were using the same denominator for all those values. So work problems, we don't have that, which is why one of the key parts of this is we have to find the least common denominator to work these out. And there are a couple of ways that we can work around this and make it very sorts of easy to get through. And if you pay attention to the way these pieces interact and work with each other, it's a lot easier to get this done. So problems at their basics are just really just adding rates together, and we need to find that average rate between the two working So I'm going to work through a few examples, and it's probably the best way to kind of get your handle on this. So we got Sally and Billy here, and I've already worked this problem out completely, so you can just kind of stare at it, and I'll point to things as we go. So we got Sally and Billy in here, and they're painting a room, and we know that together they can paint the room in 2 hours, and Bill can paint the room by himself in 3.5 hours. So how long does it take Sally to paint the room by herself? So one of the things I do want to point out here is, first and foremost, is that the time it took one of them to do it is more than the time it would take for them to do the job together. So if Bill's time was less than 2 hours and together it took them 2 hours, there's something wrong there, because the time for them combined has to be less than their individual times. Now, then some people, the temptation is to say, well, it took her 1.5 hours. Because they want to subtract them. Well, remember, these are fractions though. And the time, if you look back, remember what I told you here, work over time. So what we have here is 1 over S, 1 over Sally's time, 1 over 3.5, that was Bill's time, 1 over 2, because that was their time together, one job per unit of time. So the S, which is Sally's time, is the one we don't know, and it happens to be the denominator. That's why we have to have a common denominator in order to deal with these things. So what I went and did is I multiplied both sides by 2, by S, and by 3.5. Got a little messy there, sorry. So 2 and S and 3.5, right? And when I do that, I cancel on the right-hand side, I cancel out the 2's. And then on the left-hand side, well, I got to distribute this through, right? And when I distribute it through, I get cancellation of individual pieces. And that's where I get 3.5 times 2 and 2s. All right. So then it's just a linear equation. I have to solve, combine like terms and all that. And when I get there, I have 7 equals 1.5, which means 4.6 is equal to s. So it takes Sally 4.6 hours to paint one room. Now, if you wanted to break that out a little bit, well, this is supposed to be 40 minutes right there. Sorry about that. So it takes Sally 4.66 hours to paint one room, or it takes her 4 hours and 40 minutes. And what I did was 6.66 was 2/3, so I did 2/3 of 60, and that is 40, which is what that should be. All right. So here's another example. We'll work this one together. So Sally and Billy again here are painting a room. Apparently they don't keep a standard time frame. Maybe it's a different size room. Together they can paint the room in 4 hours. Bill can paint the room in 3 hours. How long does it take Sally to paint the room by herself? Now before we go any further, I just want you to notice this right here. Bill's time is shorter than Sally's time. And some of you are thinking, well, so what? We can still work the problem out, right? Well, let's do this. Try 1 over S and 1 over 3 equals 1 over 4. So, okay, so we've come through, and 4 times 3 times S, 4 times 3 times S, and I take this and I distribute it here and here, right? And the S's cancel on that first one. I'm left with 12 because that's 4 times 3. On the second one, the 3's cancel, so I'm left with 4S. And then here with this other one, I get the 4's to cancel, so I'm left with 3S. So now I subtract 4S from both sides. All right, and I get 12 is equal to negative S. Which means if I want to solve for S, that means that negative 12 equals S. So it took Sally negative 12 hours. Doesn't make any sense. And that was the sole reason why I did that. I purposely set that up just to point out to you that these times really do matter. You have to pay attention to that. So if you get a problem where those one individual's time is less than the collective time, then you know that that problem just can't be worked that way. Okay, so that one had no solution because the problem was bad. So let's go back to example 3 here. And here's another one that this one does work. Now, the thing is, I didn't give you tons of information on here. So Sally and Billy are painting another room. Together, they can paint the room in 5 hours. Bill takes 1 hour longer than Sally. How long does it take Sally? So here, the only number I actually gave you was the time together, which is was 5 hours, which is where that 1/5 came from, right? So where the S and the S plus 1 came from? Well, I know right here it says Bill takes 1 hour longer than Sally, right? So if it takes 1 hour longer, that means that you have Sally's time plus 1 hour is 1 hour longer. So that's where the 1 over S plus 1 comes from. So again, I multiply both sides by the common denominator, which in this case is S plus 1, and 5. Here, 5S and S plus 1. 5's cancel over here. I get the S plus 1's. And again, I have to distribute this into both parts, both pieces, right? And when I do that, I get cancellation in different spots and different types. And then I need to do another factoring there, combine like terms. And here I end up with a quadratic. Now, I didn't go through the whole quadratic for you. There's a whole another video, but right there is a quadratic. And this one didn't look like it factored very well, so I just went straight to the quadratic formula, where a equals 1, b equals -9, and c equals -5. And when I got that, I ended up with two values, -0.52 and positive 9.52. This one I'm going to throw out. There's my value right there, okay? Because that means Sally takes 9.52 hours, okay? And then how long would Bill take? It didn't ask in the question, but if we were looking for it, we would be looking to do that. All right, so we just add 1 to that. And that's all we got for this one. If you have any questions, please let me know. I'd be more than happy to answer those as quickly as I can.